All right.
All right, we're live.
We are live.
Hey, pal.
Hey, good morning. It's good to see you, Wyatt. How you doing?
I'm doing all right, Perry. Thanks for asking. Yourself?
Doing great.
Nice.
Well, I'd like to welcome everybody to another Industrial Logic Live streaming event. Thank you all for logging in and joining us today. I think this is going to be fun. This is a really important topic. We're going to spend about the next 30 minutes or so talking about ways to rescue legacy code and share some of our experiences in doing that. I think this is an extremely important topic and one that will likely affect every developer out there at some point in their career. So before we get started, let's take a minute and introduce ourselves. So Wyatt, who are you?
I'm Wyatt Sutherland. I'm a senior consultant at IL Industrial Logic. I've been, helping organizations for the last 26 years on how to do agile and actually apply modern software development, testing, design practices to their team and
Oh, that's
organizations. So,
very good.
yeah.
Um, I'm Perry Reid, also a senior consultant with Industrial Logic, and I've been doing software consulting for well over the last 2 decades, but I've been a software professional for well over 40 years. So a very long career and one that I find immense value in. Um, but yeah, the last couple of years, just like Wyatt, I've been doing a lot of work with clients, helping them find ways to build better software sooner. And this topic today, I think, is a great one to be talking about because this idea of legacy code gets in our way a lot of times. So we're going to spend a few minutes. So let's start there. Wyatt, this is and before we go any further, let me encourage any of you that are out there listening. If you have any questions or comments, please post them into the chat session. We'll do our best to answer any questions that come up during the session. And if those of you who are watching, maybe after this session is recorded and you're watching the recorded version, I'm sorry, but you're just going to have to call up Wyatt personally and ask him your questions. His mobile number is 608-555-4321.
Yeah. If you
So,
have any questions about my industrial kitchen, which is really, it's a real kitchen. Yeah.
so
In my barn. It's a kitchen in my barn.
absolutely. So anyway, let's start with the basics. We're talking about legacy code. What is legacy code? I think that's a decent question to
That's a
start with.
great question. Yeah, it's a great question. God, I wish we could actually talk to the people who are, you know, in the audience. So hopefully they'll post some questions.
That would be great.
Yeah. You start, Perry. So I think we're, yeah. What is legacy code? What does legacy code mean to you, to me, to us?
Yeah, well, it's a term that's thrown out a lot, and oftentimes it carries a very negative connotation. It's code. Often people refer to code that's difficult to understand or difficult to change as being legacy code. Many times it can be as simple as it's just old code that somebody else wrote and they're no longer here, and I don't know what it does, kind of thing. Um,
Or
but
code that I've written in a previous life, and I'm looking at it,
exactly.
it's like
So
I sure
definition
I
that
sure did learn a lot between last time and now.
exactly. So definition that I came across when reading Michael Feather's book on working effectively with legacy code, he gave an interesting definition. He called legacy code is any code without tests. And when I read that, I thought, man, that's a very interesting definition because if you think about it, if you're writing brand new code, if I'm writing code today and I'm not writing it, with quality test first kinds of practices like test driven development or whatever, if I'm writing code today without tests, according to Michael Feathers, I'm writing legacy code. Now
Yeah, I
that
wonder, Perry. I wonder if he means um, instead of automated tests, because is he referring to automated tests or like
yes,
any test?
No, I think he's referring to automated test.
Right. So how about if I had like a full regression suite of tests for some old code and all this like huge monolithic requirements documentation that, tells me about behavior and outcomes and outputs and stuff like that. Would that make you feel better?
Well, having any test at all defined is better than nothing, because many cases, teams or organizations, they don't have it, or if they do, it's often manual, and it's stuff that's only run or executed at the end, maybe just before a release goes out.
Yeah.
And it's because it's not automated. It's one of those things that gets kind of deferred to later. And this gets back to one of the core tenets that I know we share with a lot of our customers, this idea of rapid feedback.
Yeah.
And that's where automated testing makes all the difference in the world.
Yeah.
If I can write a line of code and run my tests, not just the ones for that little bit of code that I just wrote, but literally all of the tests for the system, if I can run those every time I make even a small change, I can catch problems before they ever escape. So
Yeah, very true.
but I think there's something about this idea of legacy code being difficult to understand, difficult to change, and difficult to maintain that gives it, this negative connotation. And when we talk about this topic, this idea of rescuing legacy code, I really think that it's important for us to understand what legacy code is, and what does it feel like to be working in legacy code. So Wyatt, in your experience, when you've been in an environment where the code is difficult to understand, difficult to change, what are some of the things that you might feel, or what are the symptoms that you might experience that tells you that, hey, this might be some legacy code I'm dealing with?
Yeah. Well, I mean, I remember uh, early in my career having to dive into code that was sort of outdated. Some of the languages that we were using were sort of antiquated, and yeah, I felt really nervous, especially when the manager is saying, "How long is it? How long do you think it's going to take for you to add this new feature?" And it's like I had not an effing clue,
Yeah,
and I would like grab an estimate out of the air and just the estimate of the day and hope for the best. But yeah, I would feel. I wish I knew then what I know now in the last couple of years is, you know, adding characterization tests, doing mutation testing, things like that to understand the behavior of the code that I was about to, you know, go
sure.
into.
Yeah, absolutely.
Hey, someone just said, Fortune just said to me, legacy code as a term, has a feeling of outdated languages, outdated design. Yeah, there you go. Perfect. So it's riddled with tech debt. Yep, exactly.
No, that's great.
Yeah,
Yeah,
yeah.
absolutely.
And I wonder like how people handle the legacy code, right? I mean, because we talk about, okay, if you want to understand the behavior, the first thing we want to do is wrap it with some tests, right? Get
Yeah,
coverage, wrap it with some tests, do some mutation testing to make sure that we have um, the right tests, to understand the behavior, and then start refactoring so that it's cleaner and has a better design to it. I'd
yeah.
be really curious to hear how many people are, like applying those practices and that way of working in legacy code.
So a minute ago, when we were talking about, what does it feel like to be working in legacy code? You mentioned feeling nervous. Can you
Yeah.
elaborate on that a little bit?
Well, I mean, um, so in a previous life, I was a cellist, right? You know that.
I do know
And
that.
so, and I played professionally, and there were times when I didn't feel I didn't feel comfortable about going on stage because of my lack of preparation or whatever that. And I would get this tingling feeling on the back of my neck, and I'd get these like massive butterflies and Godzilla-sized butterflies in my stomach. Well, I mean, when I'm looking at code that is snarly like that, it really does. Yeah, I have a physical reaction to it.
Mm. Yeah.
So yeah, it makes me nervous.
Yeah. So, that feeling of being nervous, I think is magnified many times over in the absence of automated tests.
That's right.
The automated tests that we put around our code gives us confidence to make changes, and because we know that if we make a change, the tests that we've created form a safety net that will catch us if we've made a mistake. If we've created code that breaks some other part of the system.
Perry, here's one for you.
Yeah.
So you and I have been in a number of organizations where the organization has the snow cone of the testing pyramid,
Yeah.
right? So the emphasis is on the end-to-end behavior-driven test.
Yeah.
So someone would go, "We've got tests wrapped around every freaking behavior of the system."
Yeah.
Is that what you're talking about?
Absolutely not.
Okay, so
Yeah.
go on.
So what's interesting about that is that there's a place for those end-to-end tests, those tests that drive the behavior through the user interface. But when we talk about Mike Cohn's testing pyramid, it represents the smallest part, the very top of that pyramid. And one of the reasons why that is, and at the base of that pyramid are those small unit, what we call micro tests. And there should be literally hundreds, if not thousands of those. They should be small, they should be fast and responsive. So, when you're writing the code, you want to be able to run those tests quickly. The problem with those end-to-end tests is that they are usually more expensive and time consuming to create, and they are slow to run.
Yeah.
And not only that, they're often brittle. So there's a lot of, challenging things about those end-to-end tests at the top. They can be used, and they're often used to drive up your code coverage statistics because they will count as having exercised certain lines of code. But a test that you only run maybe at most once a night, but often, only once every, several days or maybe even once a week, is not nearly frequent enough to give you the feedback that you need.
That's right.
And so teams of, developers that understand this, they are building safety in at a level that they can get feedback rapidly, literally with every line of code they change. They can have to test run.
Microseconds, milliseconds.
Yeah. So, one of the things that's interesting about this, we talk about legacy code and we've got kind of an idea of what that is, but there's this other term that's often thrown out there, this idea of technical debt. So, tell me what your thoughts are about technical debt and what relationship does that have to legacy code?
You talking to me or are you talking to the audience?
I'm talking to both, I guess. But since they can't answer me directly, I'll ask you.
Yeah.
What are your thoughts about technical debt? First of all, what is it?
Yeah. So technical debt. So imagine when we have to, when we go into code and if it's spaghetti or if it's poorly designed or it doesn't have any feedback loops, we don't understand the behavior and understand the behavior we have to look at a requirements document. Technical debt is that extra work when we have to fix something to make it more efficient, make it more of an efficient solution when delivering the software. So in the world that you and I work in, we are continuously refactoring, right? So we write code, we see some smells, we'll refactor it. That is a way of keeping debt down. Now, what often happens is that we will get into a code base. We see a conditional smell, if else, whatever. And someone says, hey, we've got this new sort of type or condition that we have to accommodate for. Well, What most people do is like, let's slam it in, let's add another if else statement. Now this conditional becomes is debt. Like in the beginning, we didn't mean to create the debt, but over time, right? And so we would add more code. We would walk through a debugger and then find a way of putting in some sort of result or outcome.
Sure.
That's debt that we're incurring over time. Is it's adding to make it's adding more complexity to the code, um, unnecessarily. So it makes understanding it more complicated.
Yeah. So I've spent a lot of time over the years getting acquainted with this idea, and it's a term that's thrown out a lot. Developers will often say that we've got mountains of technical debt in the code, and if you go back and research the origin of that term, you basically go back to Ward Cunningham, and his early work in the XP space. He used it as a metaphor to describe what he was experiencing, with the software. That when you're working with the software and you have a certain level of understanding about the code, that over time your understanding of what those objects are and what they ought to be doing evolves and change and grows. But if you don't take the time to go back and modify the code so that it aligns with those new understandings, he says that you basically keep tripping over that uh, disconnectedness and the understanding. The code has one level of understanding. You currently have a different one. If you don't use that opportunity to modify the code, you're going to keep tripping over it. And he used the debt metaphor when explaining to his boss. He said, we need to pay down. We've borrowed some money. We've gone a certain direction in the code base. It's time that we take we take a little bit of time and go back and refactor the code so that it aligns with our current understanding. I tell that story because a lot of times people use tech debt as an excuse to basically write bad code with the promise that they're going to go back and fix it at some later time. Ward basically said you should never intentionally write bad code, with the expectation that you're going to clean it up later. So, you write the code, to the level of your current understanding. And when that understanding changes, you should modify or refactor the code to improve. And I got this example from Mike Reeser, another colleague of ours. He used the example of a professional kitchen. When you have a professional kitchen and a chef, they have a sort of clean as you go policy. They don't let everything pile up and things get, really dirty and messy in the kitchen. They have to keep the work areas tidy and clean at all times because they're constantly using that environment. It's the same thing for software developers. We need to refactor as we go. We need to be cleaning the code up as we make these little messes. As we're writing the code, we recognize it, and we should be cleaning those things up.
So there's a caveat in that, Perry.
Okay.
Oftentimes in professional kitchens, the chef is not the one who's cleaning up,
Exactly.
right?
Yeah.
So it's somebody else who's cleaning up. So I'm going to another station and someone is coming behind me and cleaning up. So I'm quite confident knowing you that that's not what you're advocating.
No, absolutely. So we got another little question here. Fortune says it's also add quick fixes that linger too long, unfixed defects, deprecated technologies that have never been upgraded due to the budget, austerity, patchwork designs that prevent you from extending the code to add requested new features, all make it impractical to do so. Yeah,
That's right.
and that's the fascinating thing about software is that one, it's literally different every time we do it, and it's always a little bit of a moving target. We may have mastered a certain technical stack, and we think we're going to be using that on this project, and lo and behold, you get into it, and there's some whole new set of constraints or capabilities that you have to integrate.
Yeah.
One last thought about technical debt is this idea that it never starts out this way. I mean, when you start writing on a new project, let's say it's a greenfield project, you expect everything's just going to be great, right? It's all going to be wonderful. It's all going to be clean. But there's this little thing called the second law of thermodynamics. You know that one, Wyatt?
Yeah. You've said this before. Yeah.
Yeah. It's technical debt's a lot like entropy. It just happens naturally as small little changes
That's right.
get made to the code. It eventually deviates from maybe that original clean, desired design.
Exactly.
And it just gets a little fuzzy, a little ragged around the edges, and it stays that way until you invest energy into it. And that's the same thing with entropy. Things go from order to chaos kind of all on their own, and they will continue to go that way unless you insert energy back into the system.
Yeah, it's always best. I mean, Fortune says this perfectly: tidy first. Just keep tidying as you go along. It's like you take your socks off. You don't want to throw them on the floor and just like put them directly into the hamper or, someplace. But yeah.
Very good. So moving on just a little bit, this talk is about rescuing legacy code. So now that we understand a little bit more about legacy code, why does legacy code need to be rescued? What is that all about?
Well, the code will likely be in use someplace, right?
Yeah.
And if it's not in use, then there's probably no reason to rescue it. Meaning, you can put a sniffer on it and see if anything steps into the code. But if it is being used, and if Perry, you're my manager, and Wyatt, I want you to add this new capability, and if I go into it, it'd be really nice if I could just make it cleaner for myself, for anyone who's going to work on it. It's the whole Boy Scout or the Girl Scout or Cub Scout rule. Make it cleaner, leave it cleaner than the time that you entered into it. It just makes it simpler all around, especially if it doesn't have any safety nets or feedback loops in it. That would be so invaluable to add. I mean, it saves so much time when you know how the code behaves.
So, like I said earlier, the term legacy code carries a lot of negative connotations about it, and so there's this question that if it's all that bad, why not just throw it away and rewrite it? Right?
Yeah.
What's interesting to me about that is, that ugly code that you may be frustrated with. If it's in use, that code is making money for your company, maybe helping run a multi-million-dollar business. So there is intrinsic value in that legacy code. And there are a lot of people that think, they get to a point and they say, oh, this code is horrible. What a mess. We should throw it out and start all over. But I was sharing this with you the other day, Wyatt. I remember reading an article years ago by a guy named Joel Spolsky.
Oh, yeah.
I think the title of the article was Things You Should Never Do, Part 1.
Mm-hmm.
But in that article, he talks about, he gave some examples, historical references to companies that had code that they felt was a mess and decided to throw it out and start all over. And one of the selling points for doing that was that, this will all be brand new code, as if code rusts or something over time. So, and he gave this example, and one of the examples he gave was Netscape. And if you remember back in the early days,
my gosh,
everybody on the planet was using Netscape. It had a stranglehold on the market share. And then they came out and said, we're going to completely rewrite Netscape from the ground up. It's going to be wonderful. It's going to be beautiful. Just wait and see. And so everybody did wait, and they waited over 3 years.
Oh my God!
For that new code to come out. And meanwhile, Microsoft came out with Internet Explorer, and the rest is history. Nobody's using Netscape today. I mean, That code base found its way into other things, other browser technologies, but Netscape totally lost their market share by assuming that they needed to throw away what they had rather than rescuing it and improving the problems that they had internally. And the problems, every time you make a change to the code, it's usually to address something. You're either adding new functionality
That's
or
right.
you're fixing a defect. When you throw all that away, unless you've carefully articulated exactly the feature set that the old system had, it's going to be difficult to replicate. And all of those bug fixes and nuanced changes that it didn't work quite right on some other hardware or some other browser technology gets lost, and then you have to repeat all that learning again on a new code base.
Yeah. Well, I mean, Fortune actually is talking about something that we talked about yesterday or this morning. I can't remember. But one of the strategies is to strangle it, right? And strangle it incrementally, right? So let's say that we have all these tests that provide the feedback loop for the behavior. We could start, if it is that snarly and we have to throw it away, we wouldn't do it like Big Bang. It's like, let's just take increments of it,
Yes.
over time. And using that strangle pattern.
Yeah,
A
the
really good
strangle
book.
pattern is great because it really is safe. You can have the existing implementation there and slowly transfer the functionality to a new pattern, a new design.
That's right.
And slowly over time strangle out the bad code.
Yeah.
So thank you for that comment. So let's talk about how to rescue legacy code. So hypothetically, let's say you've just been put in charge of a legacy code project, and you find that it's really difficult to maintain. How would you plan to improve it? What are the things you're going to do to make it easier to maintain for the long term?
Well, first thing I would do is add characterization tests if it doesn't have feedback loops. That's the first thing I would do, right? It's like I wouldn't refactor anything. I'd understand the behavior. I do some mutation testing to see if there are any tests that I have, not. I mean, you can have 100% coverage and still not have all the right tests, right?
Yeah, true.
I mean, we've seen that and we've shown that a number of times. And so this 85% test to code coverage when you're going to SonarLent, that's a false false positive. Is that the phrase? Yeah. I mean, it's
Yeah.
so anyway. So I would make sure that I had the right characterization tests, and I would do some mutation testing to see if the tests stay green or hopefully they turn red, and then add the proper test for it, and then I'd start refactoring. And then if we say, oh wow, this is a lot of refactoring, we can have a better design. Well, I mean, maybe then we create some sort of parallel path and apply what Fortune was saying. Start applying a strangler pattern, to the code base. Well, those are all strategies, up for discussion with the team and other folks who are going to hopefully participate in this.
So we've got a few minutes left. I'm thinking, are there any other stories or experiences you've had, Wyatt, that you want to share?
I find it fascinating that every organization, literally every organization we go into, we are faced with this legacy code, and people do not know how to, or they feel insecure with, or they have not practiced various techniques for getting on top of legacy code.
Yeah.
I mean, the first thing that people think of is when we replace it all, or they don't even understand like characterization mutation testing. So that would be something that'd be great for people to be able to wrap their heads around.
You mentioned this earlier about the nervousness that you feel when interacting with legacy code, and tests are our friend, right?
Yep.
One of the things that I think is the most powerful aspect of working with legacy code, as you said, characterizing the behavior that's there, so you know what it is supposed to be producing.
Yeah.
And those tests, when they're in place, it makes it possible to systematically begin to improve the code through
Saves our butt, man.
doing all of that. So we're just about out of time, and man, the time goes by so fast. Any final thoughts you want to share before we say goodbye?
No, I just did it. Yeah, please. If anyone has any last questions, ask them now or hit us up. You can come to our IL website and industriallogic.com and look us up and send us a note, whatever.
Well, I think that's it. So, Wyatt, thank you so much for your time. It's always a pleasure, man. Enjoyed it so much.
Indeed. All right.
Thanks for all the comments and questions, and watch the space for another live event. We've been doing them pretty regularly, so I'm sure there's some more coming up in the next week or two.
Yeah, fortunate. It was really great seeing your comments. Yeah, stay in touch.
All right, and that's
Cheers,
it.
man. Okay.
Thanks so much. See you soon.
You.